Welcome to Unit 6, Lesson 2, Derivatives of Exponential Functions. So let's say that a student has $1 right now, $1, and after every day, the amount of money that she has doubles. Doubles is 2 times. So after 1 day is $2, 2 days $4, 3 days $8, and so forth. 16, 32, 64. So it doubles every day. What would the derivative, so what function? The function would be f of x equals 2 to the x power. That function describes how much money the student has. What would the derivative look like? Well, derivative is rate of change. It's the slope. Let's think about this. From 0 to 1, the change is 1. From 1 to 2, the change is 2. From 2 to 3, the change is 4. And then 8. And then 16. And then 32. And so forth. So the derivative of f of x equals 2 to the x should look like 2 to the x itself. It looks like it. It also is doubling. But notice that it's not doubling the same way that x is. When we're increasing by 1, when f of x is in between 1 and 2. And so we see that this is f. This has to be what f prime of x looks like, the derivative. But this is slightly off. Like 1 is between 1 and 2. F prime of x equals 2 is between 2 and 4. F prime of x is 4 is between 4 and 8. So we're kind of delayed. So really, it looks like it, but f prime of x is actually 2 to the x times some constant. We're off by a little bit. We're going to have to figure out what this constant is going to equal to. Okay? So we will come back to this question. But we know that the derivative should look like 2 to the x times something. What about the derivative of e to the x? Remember that e is special? Well, let's figure out why e is special. Let's find the derivative of e to the x. Again, the definition of the derivative we've been using, f prime of x is equal to, as the limit as h approaches 0, f of x plus h minus f of x over h. So if f of x is equal to e to the x, then that means that f prime of x has to equal to, we use this definition, it's going to be the limit as h approaches 0, e of x plus h minus e to the x over h. Now remember our rules of exponents. E to the x plus h power is just e to the x times e to the h. Okay, and then the rest of the derivative is minus e to the x over h. There is an e to the x in each of these two terms. So we can factor out an e to the x. So this is really equal to e to the x, e to the h minus 1 over h. Okay? Now notice that e to the x doesn't depend on h. So this is really just a constant with respect to h. When h changes, e to the x does not change. So if that's a constant, using what we know about limits, we can pull it out in front. E to the x times the limit as h approaches 0, e to the h minus 1 over h. So we know that if f of x is e to the x, then f prime of x is also equal to e to the x times this constant, limit as x goes to 0 of e to the x minus 1 over h, right? All right, what is that limit equal to? Well, let's just graph this on decimals and see what it looks like. So what we have here is we have e to the x minus 1 divided by h. And instead of using x, we're going to use x so that we can graph it. All right. Let's look at this graph. We want to know what happens when x goes to 0. Well, when x goes to 0, we can see that the graph approaches 0 from the positive side. When it approaches 0, the function is heading towards 1. From the left-hand side, the negative side is also heading towards 1. So we see that this limit, as x approaches 0, this thing is right here, is 1. So this whole thing is equal to 1. Well, if this whole thing is equal to 1, then that makes it easy. It's e to the x times this whole thing that's equal to 1. E to the x times 1 is just e to the x. Okay? So what did we find? Well, we find that if f of x is e to the x, the derivative f prime of x is also equal to e to the x. That's what makes e to the x special in calculus. It's the only it's the only family of functions in which the derivative is the same thing. I say family because 3e to the x, the derivative is still 3e to the x. Yeah. So to summarize, if f of x is e to the x, then the first derivative is e to the x. The second derivative is still going to be e to the x. The third derivative is also going to be e to the x. Okay. Let's confirm that if f of x is equal to e to the x, then the first derivative looks the same. Second derivative looks the same, and so forth. It's the same function. Okay. So we know the derivative of e to the x is e to the x. What about the derivative of a to the x? So now the base is not necessarily e, it's any number. Maybe 3 to the x, 4 to the x, and so forth. Okay, let's figure it out. To figure it out, I'm going to review something. Remember that e and ln are inverse. It's kind of like addition and subtraction. So e to the ln 5 is just 5 because they're inverse. So e to the ln a is just a. Well, if e to the ln a is just a, that means a is e to the ln a. That means that a to the x power is the same as e to the ln a to the x power. So a to the x is e to the ln a to the x power. But using our rules of exponents, that's the same as e to the ln a times x. Same thing. An exponent to an exponent is just you multiply the exponents. Okay. So we know that a to the x is equal to e to the ln a times x. Well, this gives us a form that we can differentiate. We will differentiate e to the ln a times x. So f prime of x, well, we know the derivative of e to the x. Derivative of e to the x is just e to the x. So the derivative of e to the ln a times x is e to the ln a times x. But chain rule, we have to multiply by the derivative of the inside. Remember, the derivative of 3x is just 3. 4x is just 4. Yx is just y, if y is a constant. So ln a x, the derivative of ln a times x is just ln a, because ln a is a constant. But of course, e to the ln a x is just x. Sorry, it's just a to the x. We're going back to what we just did. So this is just equal to a to the x times ln a. So we found that if f of x equals a to the x, so any exponential function with base a, the derivative is just itself times ln a. And we predicted this earlier. We said earlier it's going to be the derivative of 2dx is 2dx times some constant. As it turns out, that constant will be ln 2. Okay. So to summarize, what did we learn? We learned that if f of x is e to the x, f prime of x is also e to the x. If g of x is a to the x, a is any number, then g prime of x is a to the x times ln a. Okay. Let's look at some examples. Number 1, f of x is 4 times e to the 3x plus 5 power. Then the derivative is going to be 4. The derivative of e to the 3x plus 5 is e to the 3x plus 5. But then chain rule, we have to multiply by the derivative of 3x plus 5. Derivative of 3x plus 5 is 3. So to simplify, that's 12 times e to the 3x plus 5 power. That's it. Number 2, g of x is equal to sine of 3 of x. Then the derivative of g prime of x, well, the derivative of sine is cosine. So derivative of sine of 3x, nope, sine of 3 to the x is equal to cosine of 3 to the x. That's the derivative. But chain rule, we have to multiply that by the derivative of 3 to the x, which is 3 to the x times ln 3. Okay. Number 3, h of x is e to the x plus 3 over 5 to the x. We have to apply our quotient rule, low d high minus high d low over the square root of what's below. So low is 5 to the x times d high, the derivative of the top thing. The derivative of e to the x plus 3 is just e to the x, because the derivative of e to the x is e to the x. Derivative of 3 is 0. Minus high, which is e to the x plus 3. D low, the derivative of 5 to the x is 5 to the x times ln 5. All of this over the square of what's below. So all of this over 5 to the x square. But applying our, so this whole thing, square. But applying our rules of exponents, 5 to the x squared is just 5 to the 2x. So really, the top stays the same. I'm going to copy and paste the same thing. But 5 to the x is just equal to 5 to the x squared. It's the same thing as 5 to the 2x power. Okay. That's it.